Good evening, one and all. Myself, Dr. A. Sudhakar, working as Professor, Electrical and Electronics Engineering Department, Gates Institute of Technology, Gutti, Andhra Pradesh, India. So today I am going to give presentation on monitoring and speed control of AC motors using pulse width modulation technique. And my paper ID is 21397. So coming to the presentation, so the abstract of the paper is, we all know that AC motors are having wide range of applications, especially in AC motors compared to synchronous motors. Majority of home appliances and the industrial applications were using induction motors. So today we will be discussing on the speed control of the induction motors by pulse width modulation technique. So in pulse width modulation technique, so by controlling the width of the pulses by T on and T off with respect to the total time period, we can control the speed of the induction motor. So the induction motors are having various applications in HVAC systems, industrial automation, etc. So the effective monitoring of the speed of the induction motor is very essential in today's different applications as mentioned by me. So now today we will be discussing about the effective monitoring of the speed of the induction motor. So here with respect to synchronous motors, there will be different faults like electrical faults, mechanical faults, and environmental faults. And even if we observe the induction motors, okay, so we'll be observing so many faults with respect to induction motor due to overheating and the temperature, the excess current drawn due to faults, different faults. So here, if we observe the block diagram of monitoring system of an induction motor, so there will be different sensors like voltage sensor, current sensor, speed sensor, and temperature sensor. So these particular sensors will be continuously monitoring the different parameters like voltage, current, speed, and temperature of the induction motor. So here there will be a interface to Arduino Uno. So this Arduino Uno will be continuously accessing the data from the sensors, and it will be updating the data to the cloud. And this data can be accessed remotely by a mobile or any computer by an app. Okay, so and we can continuously monitor the status of the induction motor. So in addition, we can connect a speed controlling circuit to this particular Arduino Uno. So we can have an LCD display connected to the Arduino Uno to continuously observe the observe the status of the different parameters. So this is the overall block diagram for monitoring and speed control of induction motor. So here, if we observe there is an Arduino Uno connected, and it is getting data from different sensors, and it is providing the data, and it is continuously uploading the data to the cloud. And we can access the data from the cloud through any apps remotely through a mobile or computer, and we can get the status of the three-phase operation of the three-phase induction motor. So this is the circuit diagram of the monitoring system of a three-phase induction motor. So this is the hardware model which we are connecting. So we can observe a induction motor and the Arduino Uno board and a mobile connected. So the status of the induction motor can be continuously monitored remotely by a mobile. So this is the LCD display where the different parameters like temperature, voltage, current, and speed can be continuously monitored. So these are the different readings which can be observed through a mobile, the temperature, voltage, current, and speed. So if you observe for a temperature, for different temperatures, whenever a high current of that 135 amperes is drawn, the speed level is 4. So the voltage is almost maintained at 230 volts. So whenever the motor is connected by voltage of to constant voltage of 230 volts, so there is a change in temperatures from 27 to 30 almost. So the different stages of the induction motor are monitored continuously. So here, by even by LCD display also, we can monitor the status of the induction motor. So we can observe the temperature, input voltage, output voltage, and current drawn, and the different at different speeds. So all these parameters are tabulated at different operating conditions. So starting from 0 speed to increasing by to 1360 rpm, 1821 rpm, 2043 rpm, 2332 rpm. So the different values of temperatures, currents, and output voltages can be observed in this particular table. So whenever these parameters, voltages, currents are graphically represented with respect to time, can be observed in different graphs like this. So the current with respect to time, then temperature with respect to time, then speed with respect to time. So with this, we can conclude that the speed, the status of the induction motor can be continuously monitored by using apps like ThingSpeak app, which can be installed in any mobile. We can continuously monitor the temperature, speed, current, and voltage of the induction motor. So the continuous monitoring of the induction motor, we can, if at all there is any rapid change which is observed in the currents or speeds, definitely due to any faults, we can immediately take action. And moreover, if at all we need to control the speed of the induction motor, it can be controlled by the speed control techniques like pulse width modulation technique. So hence the effective monitoring of the induction motor definitely will result in improved performance and longevity of the induction motor. So in this way, the necessity of monitoring of the induction motor is very essential for different applications, whether it is industrial applications or household applications, where induction motors are used in a wide range. So thank you for giving me this opportunity.